Okay, it should be recording. Okay, there we go. It's recording. All right, let me see. Where is what I'm looking for? Where is it? There it is. Okay, so this is 4.3. Yeah, 4.3. That is currently uploading. But this is all something everybody has probably seen at least once. So these are logarithms, and logarithms are the inverse of an exponential. And in the sciences, I'm sure you guys are familiar with doing something in like a science class and you had to take the log of it in the computer and it gives you like a graph and makes it all pretty. That is the inverse of the exponential. And it takes things with big differences and it sort of closes the gap so you could fit it on a scale, on a more appropriate scale. So like pH is a logarithmic scale. The Richter scale is a logarithmic scale. So we'll start here. And the video does cover it. So if you had b to the y equals x, you can go back and forth between exponential and logarithmic form using log b to the x equals y. So for like number 6. We have log 4. I think that's a q equals m. So we would have b here, according to this one right here. We need to put it in exponential. So we have b, this is our x, and this is our y. So now we're going to fit it into this equation. So it's going to be b is 4, y is m, and x is q. And that's about as far as we could take this one. It's not going to be able to be solved. Let's find one that may be able to be solved. Maybe this one. So number 13. We're going to have log 13, 142 equals a. This is b, this is x, and this is y. So now we're going to have 13a equals 142. And this is one you might be able to solve. I don't know if it's solvable. I don't even think it asks for it. But you would essentially just keep, multiplying 13 and see how close you can get to 142. So here, if we started in exponential form, so for number 19, we're going to get 19x equals y.
Professor, I think you're muted.
How long have I been muted?
Not for long, just a little bit.
Like a minute?
Yeah.
So could you hear me for number 19?
Yes, but not the 18.
Okay. Okay, number 18. We've got B, Y, and X. So we're going to have log M N equals -7. And keep this one in mind as you go through the video. And just make note in your notes of where our values can be negative. Okay. So these are all going to be pretty much the same way. What B is N, Y is 4, and X is 103. So that will give us log N 103 equals 4. And I don't really think you have to solve any of these. Here's an interesting one. 10. And this will be covered in the video. So anything with a base of 10 is a common logarithm, and we don't write the base of 10. So we would just write log of B equals A. And that's how we would write this one. This one, I'll do the inverse of this one here, is related to this one. So when we have ln, what that means is that we have log to the base e. So log e equals ln. So if you have a base of e, you don't write log. You would write ln. And if you have ln, you know your base is going to be e. Similarly here, if you have the log but you don't see the base, you know that it would be 10. Okay. This involves solving them. We will do this one, this one. We'll do that one. This one will probably be in the problem section. So I'm going to skip that one. And we will do we'll do those. We'll start there. Number 29, log 3x equals 3, which gives us 3. Remember, this is b. This is y. So that gives us 3 to the 3 equals x. So what would x equal? 27? So that means that log 327 equals 3. Number 34. Log x equals 3. Notice how we don't have that base. That's because it's a 10. This is a common log. So that's 10 to the 3 equals x. X is going to equal 1,000. So that means that the common log of 1,000 is 3. So that would be 10 to the power of 3 is 1,000. For number 35, we will have ln x equals 2. So it's ln. Our base is e. Now e is a number. It's like 2.5, forever. So this one, you will have to use your calculator. And you would, round 2 places. But you will have to use your calculator. What else? Are there any other interesting ones? No, that's pretty, yeah, they're all going to be solved similarly. You're just going to take the base, which is right here, raise it to this power, and that will give you your x. So this one would be, 9 to the half equals x. But, yeah, we'll start that one. Okay, so here we're going to simplify. So this, we'll start with number 36. I assume that's the most simple. So these can also be solved through simplification. So notice it's a common logarithm, so we're going to have a base of 10. We can say it's equal to y. And that's going to equal 100 times 8. So we're going to need to remember some of the rules of exponents here. And one of the most popular ones that they like to use would be a to the m to the n is equal a to the m times n. So what I need to do is I need to try and get these to have a common base. So 10 to the y, well, if 100 is 10 squared, and then that's to the 8th, I'm going to have 10 to the y equals 10 to the 16th. So my y is going to be equal to 16. So log 108 is going to be 16. Yeah, we did that one. We'll go ahead and try this one. Number 37. 10 to the power of log 32, and I'm going to set that equal to y. So then I'm going to have, this is my base, so my base is 10, so I'm not going to write it. And it is to the power of log 32. So log 32. And here you can obviously see, since they are the same thing, the only thing that is different is the 32. So y is 32. So that means that 10 log 32 equals 32. And notice that if you have a base to the logarithm of that base, you will get whatever is here. These essentially cancel. So on a side note, if we had b log base b to the x equals whatever, another number, the same number, this is what it would be. This is sort of like an identity. So they would, the base to the log with that base is just going to equal whatever that is inside that log is. So that's an interesting one. This one you can use a calculator for that one. So number 39, remember ln has a base of e, so they will cancel and it will just be 1.06. So let's have a look at number 40. You will have ln e to the negative 5.03. And we'll just say that's equal to y. So your base is going to be e to the y is going to be e to the negative 5.03. And notice that when they are like either a natural logarithm or a logarithm to the base with that immediate base on the inside, they should cancel also. We're not going to really focus on technology, so I don't usually do those. Okay, so we will do, so for these exercises, we will do, we can do this one. We'll do this one. And we'll see what this one is. We'll see what that one is. Okay, so number 43, log base 6 square root 6. Square root 6. So what we will start, I'll just go ahead and set that equal to y. So we're going to have 6 to the y equals the square root of 6. So another thing about exponents that you have to remember is whatever root you have, you can raise it to the power of a fraction, and they're the same thing. So I would have 6y equals 6, and this is a square root, so it'd be 1 over 2, because there's that little imaginary 2 here. So y becomes half. And notice that when we rewrite it, like previously when we were saying it was a log to a base with that immediate base on the inside, it would just be the exponent. This is a case of that where they would cancel. So 6 log 8, 4. I just think that was 45. Yeah, 6 log 8, 4. All right, I'm going to go ahead and set this equal to y. And I'm just going to have that 6 just to multiply it by. So log 8 to the 4 is going to be equal to 8y equals 4. We'll consider that 6 in a minute. So 8y equals 4. So that's going to be, ooh, this one you'll need a calculator for. So what you're going to do after you find out whatever number this is, I imagine it's going to be, well, no, I don't think I can. Okay, so we're just going to, yeah, put it into a calculator. So whatever this y is, that's going to be the value of that entire expression. So you're just going to multiply that. Number 46, log 10,000. Log 10,000. Notice that this has no base. So it's common log. 10 to the y equals 10,000. So this would be 10 to the y equals 10 to the fourth. So y is going to be 4. Yeah, that's 10 to the fourth. So therefore, that whole log is equal to 4. Now 48, log 1 plus 7. All right, sorry about that. My computer just, I don't know, the screen just disappeared. So we're going to have log 1, what was it, plus 7. Okay, and that is going to be, first we need to find log 1. So we can set that equal to y, which gives us, there's no base, so it's going to be 10 to the y equals 1. And when something equals just 1 and it's raised to a power, that power is 0. So that's going to be 0 plus 7 is 7. Okay. We'll do 50, 51, and 53. ln e to the 1/3. I'll go ahead and set that equal to y. So I have base e, but I also know that when I have the logarithm or the natural logarithm and then that immediate base right here, that it'll cancel. But we'll go ahead and work this one out anyways. So it'd be e to the y equals e to the 1/3. So y is going to be 1/3. So they canceled. Now we're going to have ln 1. We'll set that equal to y. ln is base e. Y equals 1. Of course, if anything equals 1, it has been to the power of 0. So notice that ln of 1 equals 0, and also log of 1 equals 0. So those would both be points on their graphs. And what? 53. 25 ln e to the 2/5. So that's 25 ln e to the 2/5. Well, ln is base e, little imaginary e here. So they'll cancel, which means we'll get 25 times 2 over 5. which 25 breaks down into 5 times 5. And that will give us 10. Okay, let's see. All right. We'll do 62. Verification. This is a verification problem. So what a verification problem means is that you start on one side and you try to reach the other. So we are going to show, or we're going to try to show that it's true that that messy log is going to be equal to -1. So we have log 327 divided by log 4, 1 over 64. Okay, so now we will have we need something that I'll set this one equal to y1 and I'll set this one equal to y2 so that we will have 3 to the y1 equals 27 and we will have 1 over 64 y squared equals, oh no, we will have 4 to the y squared equals 1 over 64. Well, where do we go? So obviously y1 is 3, so we're going to have 3. Y, we're going to need that to be a negative. And I believe that is 3. So it's going to be -3. So it looks like it is -1. And that's what we mean by verification. Okay, that pretty much wraps it up for today. Let me stop recording. Let's see.